In this example, we're asked to find the Cartesian equation of the path of an object whose position is given by, and we're given the parametric equation. The position vector is equal to t in the direction of I plus t squared in the direction of j, and we're told time is greater or equal to 0. So looking at our equation, we can see in front of the I there is a t, so that tells me x is equal to t, and in front of the j there is a t squared, which means y is equal to t squared. Now what we want to do is get a relationship by eliminating t. So if I was to eliminate t, I can see that I know x is equal to t, and what I'm going to do is substitute where t occurs in y equals t squared. I'm going to replace the t with x. So substituting x where t is, I get y equals x squared. I also know where the path of my object begins because time is greater or equal to 0. So I know it starts when time is equal to 0. If I take that value of time equals 0 and I substitute it into x equals t, I get x equals 0. If I take the value of time equals 0 and substitute it into y equals t squared, I get y equals 0 squared, which is 0, which tells me that it starts at the point 0, 0. So y equals x squared is a parabola. It is starting at the point x equals 0, y equals 0. I've marked that in as a point on my graph, and then I have drawn in the part of the parabola on the right hand side. If you are uncertain about the direction the path was going, just pick a value for t, such as t equals 1. So x is equal to 1, y equals 1 squared, which is 1, so it goes through the point 1, 1. If that didn't convince you, pick a value of t equals 2. So x would equal 2, y would equals 2 squared, which is 4, so it would be going through the point 2, 4. And you can see 2, 4 is a point on that graph. Let's consider this a little bit further. What I've drawn here is a table of values where I have got in the left hand column the values for t. I have picked integer values 0, 1, 2, 3, 4. Then I know that I had the relationship x was equal to t and y was equal to t squared. So substituting x equals t, I have when t is 0, x is 0. When t is 1, x is 1, and so on down. Similarly, when I substitute 0 for t in t squared, y will equal 0. Y will equal 1, 4, 9, 16. So what does this mean? Well, I am looking at position vectors. The first position vector I would have, of course, would be r equals 0i plus 0j, which I have written as the 0 vector. When t is equal to 1, my position vector will equal, I have 1i plus 1j. So on my graph I have marked in the position vector going from 0, 0, the starting point, to 1, 1, the point on the curve, and I've drawn in the vector, the position vector there. If I had t equals 2, I have the position vector is, just looking at my table, 2 in the I direction plus 4 in the j direction. 2i plus 4j, and I've marked in the position vector. I've done a similar thing for the next one, 2, 3i plus 9j. So you can see those position vectors along the path of travel. Now we'll consider the calculator. On your screen you can see my calculations on my calculator. So I have gone to a graph screen. I've selected the menu, then from menu on graph entry I have selected parameter. That brings up the screen that you can see in the right top hand corner. It is expecting me to type in x in terms of t and y in terms of t as functions. So if you look down now at the bottom left hand corner, I've typed in for the x1t is equal to t because our x value was equal to t, and for y1t I've typed in t squared because our y value was equal to t squared. I've pressed enter and it has drawn the graph just like we had drawn by hand.